So let us start. So this is first class of statics and dynamics. Right. So I'll just introduce this topic today. And first of all, actually, I would like to know what are all the questions related to this particular topic you have it. So maybe the books are actually the number of hours or any kind of peripheral questions without actually going into the subject. If you have anything in your mind, you can ask me now, right? So the basic questions are, the first one is, what is the syllabus? The second question is, weightage of this topic, and along with that, the importance of this topic. Right. And the third question is books. The fourth question is number of hours. So any other questions, if you have it, you can let me know, right? So do you have any other questions? Right, okay. So we'll go one by one. And first of all, actually, the weightage of this particular topic is around 70 marks. But on an average, every topic will get around 40 marks. So average for maths optional, each topic is 40 marks. But this topic actually carries a weightage of 70 marks. So that's why actually it is one of the very, very important topic of paper 1, right? So this is actually the fifth topic of paper 1. And related to the importance of this topic, actually, earlier, many people used to ignore this particular topic, being it is one of the tough topic. Many people feel that, but ideally, this is not a tough topic. And many people actually, so they used to ignore this particular topic because actually not many of the people will teach this particular topic. And hence actually they used to ignore it. But nowadays, actually, UPSC increased the importance of this topic by spreading the questions across all other parts. That is, so we will be having in paper, each of the paper, right? We'll have section A and section B. So section A and section B, and each section actually you will have 4 questions. And even here also we have 4 questions. Out of that, the first question is compulsory. And even here also, the first question, so the first question of the section B is the 5th question, which is compulsory. And this compulsory part will have 5 different sections again, part 1, 2, 3, 4, 5, and each carries 10 marks. In that actually definitely, so this is actually one important question, and that is actually from this particular topic of statics and dynamics. You can expect questions in 5th, 6th, 7th, 8th. So all the 4 different questions actually, this topic is spread across, meaning, so the weightage being 70 marks, and this 70 marks actually you have to plan it because actually the question is spread across all, and that too you cannot ignore this particular topic. So if you ignore it, then actually you are out of competition, I can say. That's why. So though it is a little bit of complex when compared to other, but still actually you have to be aware. But actually, to my understanding, actually this is not a tough topic. So many people feel that it is tough, but it's not really tough. So if you understand the basic concepts related to this, this is actually one of the easy topic, I can say. Got it? So that's why actually you cannot ignore this topic, and the weightage is of 70 marks. And because of this importance that is spreading across all the questions, you cannot ignore it, right? And the next question is, so the books that are related to this actually, so we have actually only one book. So that is the static separate book and dynamic separate book. Both are Krishna series. So Krishna series. So 2 different separate books are there, statics 1 book and dynamics 1 book. Both you need to buy. And both of the books actually, even our material also, it was extracted from those books only. So you can go through our material also, that is also fine, or else actually you can buy these books if you wanted to go through the theory to the greater extent, right? And then actually A number of hours, actually, this is being one of the big topic. You can expect actually not lesser than 40 hours, I think, for both of these. So 40 hours for both of these topics of the statics and dynamics, but I will deal statics separately and dynamics separately. But together, actually, you can expect more than, so approximately 40 hours, right? So, and coming to the syllabus of this particular topic, right? So first I'll start with statics, and then we can continue for the dynamics. And in that, actually, the syllabus is so statics and dynamics both together, actually. The syllabus, I'll write it. Rectilinear motion, simple harmonic motion, rectilinear motion, simple harmonic motion, simple harmonic motion, motion in a plane, projectiles, constrained motion, motion in a plane, projectiles, constrained motion, constrained motion, work and energy, conservation of energy, work and energy, conservation of energy. Kepler's laws, orbits under central forces. Kepler's laws, orbits under central forces. Equilibrium of a system of particles. So this is actually the dynamic syllabus. Static syllabus involves equilibrium of system of particles, equilibrium of system of particles, work and potential energy, friction, common catenary, friction, common catenary, principles of virtual work, stability of equilibrium, principle of virtual work, stability of equilibrium, stability of equilibrium, equilibrium of forces in 3 dimensions. In 3D. Right, so this is the complete syllabus of both statics and dynamics. But essentially, we need to understand what is this topic targeting about. And what we are going to study as part of this particular syllabus is, first thing is actually we'll be studying only Newton's laws. So nothing more than that. So this topic is completely Newton's laws. Right? And in that actually there are three different laws, right? So as per Newton's law actually, so Newton's laws of motion we call. So the first law actually which states that, so every particle tries to stay in its state of rest or of uniform motion unless otherwise it is compelled by an external force. So that is a statement which states that there is a force that is needed. If at all, there has to be a velocity given to certain particle. So if you wanted to give velocity to any particle, then you need an external force. So that force actually, it will change the velocity. So if it is zero velocity, then actually it starts moving it. If it is a constant velocity, to change that velocity, then actually you need to pass external force so that actually the velocity is getting changed, and the change of velocity which we call as the acceleration. So that means actually there is a force that is needed if you wanted to change the velocity. That means if there is a constant velocity, then there is no need of an external force to maintain that constant velocity. But if you want to change that velocity, you need an external force. So this is the first statement. But the second statement actually makes the complexity. The second statement, what it states is, the force required is directly proportional to the rate of change of momentum. So the force required is directly proportional to dP by dt, where P is the product of m into V. So this is the product of m into V, which is what we call as the momentum, right? So momentum, suppose actually if I hit my hand, so suppose actually if I hit somebody with my hand, then actually there are two different ways I can hit. So one is actually I can slowly hit like this, so that actually he won't get the pain. And I can quickly hit like this, so that actually even though with the same mass, if I hit it, but because of the increment of the velocity, he feels the impact of it. So that means suppose if I hit with a ball, then actually ball which is having the same mass with slow velocity versus with high speed velocity, then actually the difference is going to be of more. So the way we are hitting is different completely, right? So that means both mass and velocity both will play the key role. Suppose if I have a small iron, so if I have a big iron ball, and if I wanted to put on somebody, then actually automatically he feels the pain, right? So even though actually the velocity is very small due to the increment of the mass, so he feels the pain there. So that means the impact is proportional to both the mass and velocity. Hence actually it is the product of mass into velocity, which is what we call as the momentum. Rate of change of momentum. Now, this rate of change of momentum, which we call this as the force, dP by dt. And here actually this force is the one actually which we are going to study in the entire statics and dynamics syllabus completely, right? So statics and dynamics, actually I feel that actually there are two different books are there, and two different books actually you need to buy. It's not the single book, right? Right, okay, fine. Right, now our syllabus, so that is UPSC syllabus of both statics and dynamics, is simple study of the force. So study of the force is nothing but, this is a single statement of the entire syllabus of UPSC stated for statics and dynamics. Now there are two different cases of this force. One is actually there can be multiple forces acting on a body, but still the body is not moving. That is, suppose actually if I take this particular pen, I am pushing from this side, I am pushing from this side. So both the sides actually I am pushing with the equal amount of the force. Now this pen is actually facing the forces on two different sides, but being these are equal forces, hence actually it's not moving. So under the influence of the forces also, this body is not moving. It's not that actually the forces are not there. There are forces, but all the forces together are nullified, and then there is no movement of this particular body. Hence actually the study of this particular scenario, when there are multiple forces acting on it, but still the body is not moving, which we call this as the statics. So the statics, we can say that when there are multiple forces acting on a body, but still the body not moving. That study is called as statics. Right? Now, if these forces are not balanced out, then in such case, actually, obviously, we expect that the body will move. Now, that study is called as the dynamics. Dynamics. If the body is moving under the influence of forces, then the study is called as dynamics. Right? So essentially, everything, if you notice, this is simply the study of force. A single statement called the study of force is the statics and dynamics. Now, actually, when there are multiple forces that are acting on it, then the analysis actually can go deeper into it. So the deeper analysis is, there are two different forces that are acting on it. So that is the most simplest case. And one case is actually a body, if it is there like this, on this, if there is a force acting on it, on this side, actually, if there is a force acting on it, and these two are actually nullified, and hence actually this body is not moving. That means actually having any linear motion, right? Then actually we can say that actually this is linearly stable, or actually linearly it is static. That means if this is F2 and this is of F1, if F1 is equal to F2, then actually we can say that this body is not moving. So this is the most simplest case. But actually, when there are two forces which are acting in opposite direction, but still actually this can move. That is, suppose I take this particular pen. Now actually I'm pushing from the top side to the bottom, and from the bottom side to the top at this edge. So at two different edges I have taken, and then actually this is moved like this, and this is actually moved from the bottom side. Then in that case, actually the body will try to move. Though we have two equal and opposite forces, but still actually the body is actually not stable because the body is rotated now. So that means when you wanted to assure the staticity of that particular body, then actually you have to assure that the body is actually not moved in the linear direction, the body is not moved in the rotational direction. So these two different activities actually will be studying under the influence of multiple forces. And again, actually under the influence of multiple forces, if you state that, there are again actually two different categories of it. So fundamental thing is actually in the entire study, we will be assuring only two different aspects. One is the body should not be moved in the linear direction. That means actually it should not be moved in any of these directions. And the body should not be rotated also, because actually if I take this particular body like this and one force is acted on this and one force acted on this, and though this is F and this is also F, and opposite forces equal in magnitude, but still actually this will try to rotate. So this will try to rotate in this direction, and this also we need to assure it. For that actually we need to define something called torque, or the moments of the forces. So that way actually we have to calculate it, and so that actually the body is under rotational equilibrium and the body is under linear equilibrium. So only identifying these two things, that is the linear equilibrium and the rotational equilibrium, is the entire study of the statics, right? But the forces can be of different kinds. So different kinds meaning, one case is actually if all the forces are coplanar forces. That is actually if all the forces are acting on a single plane. So that means actually on this board itself actually we are showing. Suppose if one force actually is acting in this way, one force from inside the board actually if it is acting, then that time actually the study is actually not this simple. So that means actually if there are three-dimensional forces, the analysis will be much more complicated. That's why actually our last topic is actually, that is the forces, so equilibrium of forces under 3D. So that is a separate topic, right? That means all the study, or 90% of the study, is actually under the influence of coplanar forces to assure the body is under linear equilibrium and the body is under circular equilibrium. And this study actually is the part of our entire syllabus of statics. Got it? So do you have any questions on this? Right? Okay. And the study of the dynamics actually, when there is a movement, so obviously actually if this force is greater than this force, that is actually F1 is greater than F2, obviously you are expecting that this body will try to move in this direction. So this is actually the linear motion. Now this linear motion actually, now if you wanted to make it a circular motion, so this is a circular motion because actually, so this is trying to rotate. But in this particular case, actually, this is the center point where actually the axis of rotation will be the top side like this. And about that axis, actually, it will try to rotate in this particular direction. Now, again, actually, the motion. So now it became two different kinds. One is the linear motion, another is the circular motion. Now, any motion can be a combination of the linear and the circular together. Suppose actually, if particle is moved in this direction, then actually, so this is a kind of circular motion with different radius at different places. At the same time, actually, there is a linear displacement from this location to this location, and both actually involving the circular and the linear displacement together. And there actually we'll be studying the body, which is a little complicated way of analysis, right? Now, if you study the entire syllabus of this dynamics, if you notice, the first one is the rectilinear motion. So rectilinear motion meaning, suppose if your body is moving, then in how many different ways it can move. Now, in how many different ways it can move, the body actually will be moving in only one way. But actually the way we interpret is different. That is, supposedly if you take the Cartesian coordinate system, a three-dimensional Cartesian coordinate system, if you take it, then actually the body is moving in space and it will be having different coordinates at different places. Suppose if you analyze the same thing in a plane, so a planar motion, actually if you try to analyze it like a projectile actually it will be moving in a parabolic path. Now here actually we were talking about only the xy coordinates. Suppose actually if the car is moving on the road, which is on a straight line road, then actually you will be talking about only the length. So that means the body can be analyzed in three different ways, in a single dimension, two dimension, and three dimension, right? Now in that particular case, actually, we'll be talking about only the single dimension and the two dimensional only. Three dimensional actually we are not touching. But actually on the other day, actually, we were discussing in the vector calculus, which is a three-dimensional motion, actually a particle moving in a helical shape. So that is the part of vector analysis where actually we are going to study a three-dimensional motion as well. But here in this particular case, actually we'll be studying a single dimensional motion and a two-dimensional motion. Now two-dimensional motion can be interpreted in different ways. In a planar way. Planar way meaning, so we have xy coordinate system. So this is the x-axis and this is the y-axis. Now actually if a particle is projected like this, then actually it is a parabolic path. Now on the xy plane, you are interpreting this as a parabola. Suppose actually, if I talk about a circular motion like this, so a particle is moving in a circular fashion. Now actually this can be interpreted as r theta, which is in a polar coordinate system. So in the polar coordinate system, you are interpreting this as a circular motion, right? The same thing can be interpreted even in a Cartesian coordinates as a circular motion. So the way you interpret is different, but essentially the particle is the same particle which is rotating in a circular fashion. But whether you look at it in the polar coordinate system or whether you look at it in the Cartesian coordinate system, that is up to you to analyze, right? Now here actually the rectilinear motion, it is talking about a particle moving in a straight line. So a particle moving in a straight line is called as a rectilinear motion. So that means, suppose if you throw the ball upward like this, then actually the ball is going in a straight line like up and it is going down like this. Now this is this is a linear motion or the rectilinear motion. Suppose actually if you take a simple harmonic motion. So the simple harmonic motion is usually a spring mass system is there. Now in this particular case, so this one actually, this is the center of mass, and if you drag till this extent and leave it, then actually automatically it goes there and it comes back, goes this way and comes back. Now if you notice, always actually it is going in a straight line path like this, and this kind of analysis which we call as the simple harmonic motion. But still this is also, right? So still actually this is also a rectilinear motion, right? So rectilinear motion is nothing but the study of a particle moving in a straight line. So maybe forward direction, maybe backward direction, maybe having a different acceleration or maybe having different velocity, but still the particle is moving in a straight line, or a single dimensional motion is called as the rectilinear motion. And the same thing can even be called as the simple harmonic motion, because out of rectilinear motion, simple harmonic motion is one particular case. Here this is the case. Got it? And that is about the simple harmonic motion. And motion in a plane. So plane means actually when two dimensions are involved. That means a particle is projected like this in a parabolic path. Then in this case actually at every point actually we need to be talking about horizontal velocity, vertical velocity, horizontal acceleration and vertical acceleration. So everywhere actually x and y together are involved. Now the combination of these two is analyzed in the case of a planar motion. But even the circular motion also is a planar motion. That means actually the particle is rotated in this particular manner. At every point actually you need to be talking about the angle r. So angle theta and the radius r value. And or actually if you involve the xy coordinate system, then actually you need to be talking about the x directional velocity, y directional velocity, and x directional acceleration and y directional acceleration. So like this actually everything you will be talking about two different dimensions. And that is up to you. How do you want to analyze? Whether you may be analyzing in the form of the polar coordinate system, or you may be analyzing in the Cartesian coordinate system. But still actually you are analyzing a particle moving on a plane. So that's what we call as the motion in a plane. And then actually, so part of that actually, so there is a projectile, and projectile also actually, so projectile is, this is the one. And then actually constrained motion. Constrained motion is actually, if a particle is actually rotated in this particular direction, suppose actually, if you take a ball and tie a thread to that ball and then try to rotate in this manner. Now, if you rotate in this particular manner, you are constraining that particle to move only in a circular fashion. That means actually you are putting a constraint on that. That means actually the constraint here it is, the r should be maintained constant while rotating this particular motion, which is in a circular motion. Only theta is varied from 0 to 2 pi, but r is maintained constant. That means one of the constraint you are introducing to move only in this particular fashion, hence this is called as a constrained motion. So this also will be analyzing to a greater extent. And then actually the work and energy. Now till this particular point actually, what we call this as the kinematics. So in our elementary standards actually we'll be studying that as the kinematics. And from this particular portion onwards, and now we are trying to introduce the causes of motion. That means the force is involved. Till now actually the particle already started rotating somehow, but actually the particle already started moving somehow, but somehow is actually the force. And that force actually, whenever there is a force that is involved, suppose actually if I wanted to lift my hand like this, then actually I need to apply some force on this particular hand. So, but how do I get that force? I need to have certain energy. So the cause of force is actually energy, and the cause of motion is the force. So these are actually interrelated to each other. So till this extent actually, once the particle is moved, then actually how it is moved, in what direction it is moving, with what velocity it is moving, with what acceleration it is moving, all such kind of things actually we'll be studying till this extent. From then onwards actually, the causes of the movement, which is nothing but the force as per the Newton's laws. So that's what actually we are going to study. And then actually, what is work? What is energy? So work is nothing but if we do certain amount of the work. That means actually if I lift my hand, then this is some work. So what is this work meaning? That means actually there has to be a force that should be involved, and there has to be a movement of certain particle that should be involved. Both force and moment, both are involved. Then actually we say that certain amount of the work was done. Suppose actually if I take the chair from this side and then actually take it on to the other side, then actually I moved the chair from one location to another location. For that I have to applying my force, and then actually I have to be moving certain displacement. Then only everyone feels that I have done some work. The work is actually moving the chair from one location to another location. But for that I need some energy, right? That means the work is delivered. But in what way it was delivered? Because I have the energy, I could be able to move. If I don't have the energy, then I couldn't be able to move it. So work and energy are two different entities, but both are equal always. Because actually there is a theorem called work energy theorem, which states that amount of the work delivered is exactly equal to the energy lost. So this is what is called as the work energy theorem. So that means because I have the energy, there is a work that was done by me, and the work is it is shown by the society as the movement from one location to another location with the help of certain amount of the force. Got it? So this is what we call as the work. And work and energy we are going to study. And then actually conservation of energy. So as per the law of conservation of energy, so energy can never be created nor destroyed. But all the sources of energy is only from the nature. So from the nature only we get the energy, but nowhere else actually you will get it, or you cannot create it, or you cannot destroy it. But it changes the form from one form to another form. Suppose actually, let us say if I'm lifting my hand like this, then actually I have to have some energy. Then only I can lift my hand. So lifting this hand, we call this as the work. And the energy actually I have delivered to this hand, hence actually it gets certain amount of the potential energy. That's why actually if I leave my force, automatically it drops down, right? Now in that case, actually, I have to have certain amount of the energy. This energy, I got it because I'm taking food. But this food actually, it was delivered by the nature. So that means actually, it only gives that. So that actually I took it. Hence actually the chemical energy is converted into the mechanical energy. That mechanical energy is changed to kinetic energy, and then actually it has acquired the potential energy. So this is how actually the energy changed its form from the chemical energy to the mechanical energy to the kinetic energy and then to the potential energy. So this way actually it keeps on changes its form, but nowhere it will lose, right? So this is actually just the changing of the form, one form to another form. That's what we call this as the conservation of energy, or the law of conservation of energy. And then actually Kepler's laws. So this is also a kind of planar motion. And if the particle is rotated in an elliptical path, then actually that's what actually everything is analyzed with the help of the Kepler's laws. There are 3 different Kepler's laws that are going to be discussed down the line, and which will judge the motion of the planet. So, or actually every planet, actually how it will be rotated, that are based on this Kepler's laws. So this actually we are going to study. And then actually orbits under central forces. So this is a master topic, and this master topic, out of that actually Kepler's laws is actually one subtopic we can say. But how actually orbits under central forces, what is a central force, and under the influence of central forces, what is the kind of motion you can expect it, and what is the acceleration you are going to expect it, what are the specific properties of these central orbits, everything we will be studying as part of this orbits under central forces. Got it? So this is the complete syllabus about the dynamics. Got it? Okay. So do you have any questions on this? Any questions? Fine. Okay. So the important areas as per the UPSC, if you notice, mostly the simple harmonic motion, actually this is one important topic, and even rectilinear motion also one of the important topic. So as a whole, actually if you study the rectilinear motion to a greater detail level, then you will be able to answer each and every question related to these topics. And then actually motion in a plane. So this is actually mostly the motion in a plane, actually the circular motion you may expect, or a combination of the circular motion and the projectiles together you can expect it, right? So most of the times actually that is the kind of case you can expect the projectiles together with the circular motion, actually you can expect the questions. And work and energy, you don't need to expect any questions, and conservation of energy also you don't need to expect any question. But orbits under central forces, this you can expect question compulsorily. So orbits under central forces and related topic of the Kepler's laws, but it was not asked any time, but it is a simple related topic. And so actually if you study to a greater extent this orbits under central forces, you can expect definitely 1 or 2 questions from this particular section. And then actually in this particular section, equilibrium of system of particles. So this actually you need to understand, and equilibrium of system of particles, actually this is nothing but assuring the rotational motion, not there. And then actually work and potential energy, actually you don't need to expect any question, and friction also no need, but common catenary actually it is important. So common catenary you can expect questions. And then actually principle of virtual work also you can expect questions from this particular section, principle of virtual work. And then stability of equilibrium. So these questions were not asked, but actually the concept is easy. You can try to understand this. I will explain to a greater detail level. And then actually equilibrium of forces in 3D also, I didn't expect any questions till this particular section also. But this is a little complicated topic. I will explain to a greater level, but so no questions were asked from this particular section also. Got it? So this is about the complete syllabus of statics and dynamics. So if you have any questions, you can ask me now.